30 plus. That's 90. Plus another 15 is 105 and a half.
And we know it works like these too.
Okay,
That's 80.
so if I have y, sorry, it's not really responding. If I have y equals 3 times x, the word that you learned in algebra, the domain, is real super important. Like the domain of this class are the 11 people in here, okay? So if you probably accidentally walked into the wrong class before and got your schedule a little mixed up, I know I have, or I'm arrived in an empty classroom because it wasn't time for my class yet. You know, so you should walk in and you're not in the domain, so you leave. Domain is everyday real life. If you go to, trying to think, like if I go to an Italian restaurant and order chips and salsa, they say actually, well, they're probably really worried about you a little bit, but they also could mathematically say that's not in our domain, okay? But that which means it's not on the menu, okay? So domain, a lot of times, what you do to start with domain is all real numbers, and then see if it's like undefined anywhere, and you have to leave those out, okay? So it's a lot like even when we take attendance to go to mass tomorrow. We have a domain.
Oh, no.
We do?
Yeah.
Yes. Are you upset about it?
Yes.
Why?
It's not you're not like sitting there for an hour and having to wear formal uniform.
Oh, well, there's going to be a lot of things. I'm sure you're much
There isn't
There's a lot of things
uniform.
you'll find.
She
to do.
looks great. She's not complaining.
Okay. So anyway, what was I saying? Oh, in mass tomorrow, Dr. O'Brien will have a domain that's different from our regular homeroom domain. She'll call out the names of only the people that are not in seniors and campus administrators. I'm going to be first administrators. Do y'all see what I mean? It's a different domain for that day. Okay. Every now and then the wires get crossed, and she'll call out somebody, and they'll say she's in campus ministry. Okay. So that's what we're doing. So what you want to do first is assume it's all real numbers, and then see if there's anything you need to take out. The only things right now that you know of, there'll be more this year, but the only things right now that can cause you problems are square roots and denominators. Those are the things where bad things can happen to us, okay? If I have a negative under the square root, I'm stuck. It's not in the domain. I cannot have 0 in the denominator, okay? So this one, the domain is all reals. I can't mess that up, and also the graph is very easy. Of 3x, 3x squared, I'll be gentle in reminding you about quadratics and polynomials and all of that. This graph looks a lot like this. It's very steep because of the slope. And I should have gone through 0, 0. I kind of missed it, but this part of the board is not very well oriented. But, I mean, you get what I'm saying. So there's all these polynomials that you graph. Quadratics and cubic functions where I can draw it without picking up my finger. It's continuous because there's nothing that's messing up in the domain. All right, now I'm going to use a little bit to change this problem. All right, so I'm going to say y is equal to 3 over x, and now all of a sudden my domain is not all real numbers. It's everything but what, Anya? 0. I cannot have 0. Okay, so my domain, an easy way to say that is if Anya says x can't be 0 by default, what does that mean?
All real numbers.
All real numbers, okay? So, anyway, you just say what it can't be, and then that means everything can be. Girls, this is real important. Some classes have trouble really understanding what that means. This means that it does not exist at 0, therefore remember this later, probably even in another class, that means it does exist everywhere else. It might not exist here, but that means it does exist at 1, 1.5, -12, it exists everywhere else but 0. Okay, questions?
Yeah. So is 0 a real number?
Yes, that's a great question. I even have like AP Calculus BC students, when they get the answer 0, they feel like they've done something wrong. But if you think about it, math is, and I give another great thing, huge math nerds. I'm like these history books and numbers, in the summer. But anyway, along with like mindless knowledge. there was, they even felt zero was kind of evil. Like they were used to counting 1, 2, 3, 4. What's interesting, when I first started counting, sorry, I don't want all this history, but you really needed only to count integers. But then as people started buying and trading and things like that, they found out that they needed decimals and fractions and things like that, but they didn't want zero for a while. For a while, they didn't even have negative numbers. I was in a hotel the other day, the one hotel in Dumbo. A reason for us to go in. And I was visiting some friends that were at the hotel that were here in New York. And when I got on the elevator, I could go up to like 17 or whatever, the rooftop. But also I saw it said -1 instead of basement. So I was at 0 and it was -1. Okay, and then like our building, the first floor is like 1, 2, 3, 4. It's a great discussion though. And freak out, you discuss all this like all of a sudden. It'll happen to us today. It's all of a sudden like we are in the Twilight Zone, Harry Potter world, or for me, like I read the Chronicles of Narnia. I read all 6 of them twice. Do you like the Chronicles of Narnia? You know, where you walked out of the wardrobe into this whole new world where there's centaurs and things like that. I read only the first Harry Potter book, and I just didn't care about that one, so I don't read it anymore. I'm sorry. I know that's offensive. But I do remember there was some shopping center that just appeared out of nowhere when they were shopping. Yeah.
Oh, yeah.
But there's some super weird things, like you may remember last year them talking about a black hole that they had like gotten a picture on in space, and that's just like there's a weird stuff out there. But guess who they look to describe the weird stuff? We can't understand it, but we can describe it. They look to mathematicians. If you're going to study medicine, guess what's going to be driving that is math. If you're going to study, physics, obviously you're going to be doing math. I mean, there's just so much of it that describes the universe. However, one of my good friends when I was in Mississippi, he was the CEO of the Power and Light company there, like our Con Ed here. It was Mississippi Power and Light. I think they changed it. But anyway, he was one of my good friends, and he said, even though he's an electrical engineer, I mean, we could talk about nerdy math stuff, and he said, even though he's an electrical engineer and he knows things that I'll teach you this year, like a sine wave models electricity and sound. And he said, it's so weird to me that there's these invisible things going through the air that we can capture mathematically and make them useful for us. Okay, so it's really bizarre to think about. I mean, if you think about when you call someone on your cell phone, or me even talking to you right now, these little sound waves that we can't see. So can you imagine like thousands of years ago if somebody had said, I'll tell you what, there's these imaginary sine waves go through the air, and one day you'll be able to talk to somebody from the United States of America to Brazil in real time. Would that have sounded crazy back then? Yeah. But we can do it. But how do we harness it? So this friend of mine, Jim, he's like, I don't understand it, but I know it's there and I can harness it. Okay? What's beautiful about some of this, I'm sorry, I'm nerdy soapbox right now. So what's so beautiful about this is for years and years, centuries, thousands of years, they've graphed things that go up and down, like at a math, like mathematicians with their tutors and different societies. But I can't imagine how it must have felt the first time they could actually hook something up to a monitor and see a sound wave, an electric wave, a sonar wave. I can't imagine how it must have felt, because all of a sudden, if you see this, everybody in here will be able to write an equation that lands right on that. And if you write the equation, you can program things and make things and build things. You gotta have the math to make that happen. They must have freaked out the first time they saw that. Whoa, that's a sine wave, which they had seen in a book that was hundreds of years old. But it's just amazing to think about. So I wanted to, don't forget your comment.
Okay.
I wanted to set the stage for that, because you didn't realize what a good question to ask.
Yeah.
Because there's just so much weirdness about zero. But let's say this, when you get zero as an answer, there's certain things that can happen, Kate. I can have 0 over 5. And some people are gonna be relieved you asked that, because that is 0, okay?
Yeah.
I cannot have 5 over 0. This board's acting funny. I don't even know what I just did. How did all that?
We just see that white thing. Hold on. Wait, don't do that, Mrs. Mary.
Thank you. See, it's not very oriented.
It's probably not calibrated.
Here we go. Did a little bit.
It's a little bit.
It's just,
You know what we're gonna do? We're gonna do this. Thank you, Nazareth. I can tell you're gonna be a huge help. Never mind that I have a master's in technology and you're very helpful to me. So. All right, so anyway, this can't have 0 on the bottom. So I'm gonna stop and talk about that. It really plays into you being able to do your homework, okay? Please don't forget your comment.
Yeah,
I'm coming to you.
I'm
Just
scared,
wait.
I'm gonna worry.
Yeah, write it down. If there were 10 people, there's 11 people in here. So if I say get in groups of 3, you wouldn't think I was crazy, but then we would need a decimal, wouldn't we, or a fraction, okay? But you could do it. If there's 11 people in here and I say divide into groups of 1, you could do it. You may think again, I'm a little crazy, or 11 people, I'm sorry. But that's already what you are, right? There's 11 groups of 1. What if I say divide into a group of 11? Well, then you're all in one group. There's one group. But what if I say divide into groups of 0? Do you see that that's totally impossible for you to do? So I like to make logic of the math.
Yeah.
Another thing about 0. I could, it's over here, I need a teacher there. Here's where it's disoriented or not calibrated. I could have shown up the wrong time today in this room, and there's no class in here, and I could say, okay, divide into groups of 5. Then there'd still be how many groups?
0.
0. So 0 divided by 5 is 0. I could say, I didn't bring any cookies up here with me, and I'm going to divide it into 11. 0 divided by 11 means you're not getting any cookie, right? 0 became necessary because I could have 5 $100 bills. I can have one $100 bill, but I can't have 0 $100. I'm sorry, but I can have 0 $100 bills, right? You could have 0 people in your club, unfortunately. Things like that. So 0 is a real number. And then they found they needed negatives. Because if you're talking about 1979 as your starting place, if you talk about 3 years before that, so you need to go backwards and forwards through the integer. But all of that evolved over a long time. And 0 was, I think, almost for a while an evil number.
Yeah, it was.
People didn't want to write
I
it.
had
Go ahead.
I had an ACT passage about it the other day, actually.
Oh, really?
It wasn't on the ACT, but it was on where I practiced once. I was
no,
doing.
yes, it was.
It was on the ACT.
Yeah.
That was the real one.
The history of Zero. Remember, and it was
Wait.
like Mesopotamia.
Yes,
India.
that was the real one.
Very
Right?
good, yeah.
Yeah, so it was on our ACT, and it was about it was left in the dust for a long time, and they asked us what that
The
meant.
Aztecs.
Yeah, the
You're doing all
Aztecs.
this in ACT.
On the
That was
ACT,
like a
it was a reading passage. It was a reading
Oh,
passage.
okay. I thought
And
they
then
were
they,
telling
like,
you
argued-
I didn't want to say get out of the class.
So they argued that 0 existed before people found out about it, and they pushed it away. No one wanted to acknowledge 0. But
Very
some
good.
people
Awesome.
had years of 0. I thought that was on my practice for some reason. And it was some I guess what is it? Worlds, cultures, I don't know, had the year 0. But some others didn't, so it was something that was debated for a really long time.
Yeah, very interesting.
Yeah.
That's
And I have one more
cool
question.
that that just happened. Okay, go ahead.
My question was, why does that equal everything except 0?
Oh, right here.
Because X is on the bottom, therefore
Right.
it can't be 0.
All of a sudden, I'm dividing, and what we're starting today is rational functions, which you all studied in Algebra 2, but I'm gonna almost pretend like you didn't. I'll move a little faster because you all saw them in Algebra 2. They have vertical and horizontal asymptotes. That should sound a little bit familiar after, I guess y'all were in geometry last year. So we're studying what are called rational functions.
What's our topic for today?
Yes, that's the topic for today, rational functions. Okay, okay.
I'm just confused. When we're saying the domain of the equation, what are we identifying and how?
You are usually telling us what we can't do, not
Okay.
what we can do, because it's a little easier to say what we can't do.
Okay.
But you do it for me, and I'm all of a sudden gonna twist that around, and it's gonna seem like I'm being hypocritical, okay?
Yeah.
Wait,
Square
but
root
then-
of x.
Is
What's the domain of the square root of x? Anybody can answer. Can you put all real numbers under the square root?
all square roots.
I prefer that,
All
but
positive real numbers, not zero.
you can square root 0.
So all positive real numbers.
It could
Zero's
be
not
negatives
positive.
too, couldn't
So
it?
all
All
positive
positive
real numbers and
integers.
zero.
All in,
All positive integers.
all in, it's not negative.
So I think that's what y'all are saying,
Yeah.
okay?
Yeah.
So your loose conversation, which I can't let you do in pre-cal, we start there and then we firm it up, okay? Because I think you'll all end up in calculus, so you've gotta get stronger and stronger and think about weirder and weirder stuff. And that, by the way, let me finish we got off on different things that all pertain to it. But in this class this year, we're gonna talk about some things that are like mind-blowing a bit, and we harness it with mathematics. Doesn't mean we're gonna understand it. It means we have maybe just entered a whole different world where we're trying to figure out how those things work. And I'm not really sure why, but math seems to be the language of the universe, and there's even been books written about it by extremely intelligent people. Like, we've gotta be able to describe this mathematically before we can do anything with it. So we've gotta look at some strange things, which to me, I fell in love with math really when I was in pre-cal. I didn't even know I liked math all that much. I mean, I was good at algebra because I'm disciplined. And I got it. But, I really like it in pre-cal. If you're not a math person, pre-cal and calculus is the place for you. There's a lot of creative, interesting, philosophical, a lot of the great mathematicians were great philosophers, like Pascal, Aristotle. A lot of them were really philosophers. So you can't hardly not think about life and how things grow and what happens. We'll do a lot of, real life scenarios as we learn math. So these are all great questions. Now my question to Kate, and back at her, the question to me. Here, you could have said, I'm sorry, I need to write over here. You should stand over here. You could have said you can't put in any negative numbers. You could have told me what it can't do. I cannot square it in negative. By the way, you can, but then you have to operate under a different set of numbers called the complex number system, which is really out there in the world. Unfortunately, somebody named the square root of -4 the imaginary numbers, but fast forward hundreds of years and we find out, oh my gosh, those are also sort of real. When I say sort of
Is
real,
that I?
yes, and people use it to actually do things, so it must be more real than we thought it was. So they're not all that imaginary. You should, I remember the first time that my algebra teacher said imaginary numbers. I didn't speak much in class because I'm super shy, but I wanted to go then, why are we studying imaginary? Like, I had that little sarcastic thought in my head, like, when am I ever gonna use this? But I'll show you later on. Right now, we're in the real numbers, so we can't square root in negative, okay? The domain of this is x is greater than or equal to 0, but you see how our language, I have to be really picky because you tend to go positives. But the square root is asking a question. All math symbols are asking you a question. The square root is what did you square to get this number? That means what did you multiply by itself? That's why, as of right now, under the real numbers, I can't think of what I could square to get -4 unless I introduce I, okay, which we're not going to right now. But 2 times 2 is 4. -2 times -2 is also 4. And so I can't think of anything I square in the real number system to get -4. I just can't answer it. Okay? This one is 10 times 10, right? So those are perfect squares that we like a lot, okay? I prefer to have that under the square root. But one like this, forgot to not be over there. One like this, we could actually type in our calculator, but all we could get is a decimal approximation. We get all of a sudden an irrational number. Okay, so let's talk about something else weird for a minute. I'm keeping on the time. How many numbers are there between 1 and 2?
Infinite.
Isn't that freaky? You have a 1 and a 2, a finite space. Here's 1 and here's 2. And friend, there's an infinite number of numbers between 1 and 2, because as soon as I named the last one I think I found, you could name the one right next to it. How close can you get to 2? Infinitely close. Most of those numbers in there are probably irrational, right?
Yeah.
Okay.
And that's like what we were saying with the open circle. Because you can
Yeah.
get infinitely close, but it's not
But
at
it
2.
doesn't, sometimes, yeah, if
And
I
all
had
the
an
numbers
open
in
circle.
between are at 1
Yeah.
and they're not at 2.
And we're gonna have some of those open circles. Your teacher in algebra 2 called it a hole in the graph. Hopefully that sounds a little
But it
familiar.
can become infinitely close to 2.
Yeah, I can get to 1.99999 and just never get to 2.
Continue.
Yeah. By the way, another weird thing, 1.99999 is its own number. But if I do 1.9 repeating, that
That's a different
is
number.
2. 1.9 repeating is 2.
Wait, but why?
I know I've had some big arguments on this in pre-calc before.
Cause you round it out, right?
Everybody get out your calculator,
It's not round.
if you have it. If you don't have it, get one. Did you bring your calculator? Just look on with the cutter. I wouldn't say you need to go like buy $100 calculator for right now, so because.
I have
I'll
extra
try-
at home, Clara.
I'll try to remember to bring one.
I have an
Oh,
extra at home.
Yeah, so make sure she gets that. So she knows your cat. She knows Cinderella?
She knows Cinderella.
Okay.
She likes her. Cinderella likes her. Cinderella does not like people.
Yeah, my cat Olaf is like that. He picks and
Olaf?
chooses Olaf, yeah.
No, it's
He
so
picks and
cute.
chooses who he likes. Okay, whereas my other
She
cat
was
has
very
likes
sick
everybody.
before
Okay.
we came. Yeah, she's getting a little bit better now. She's just like losing a lot of weight and like her ears have been down and like throwing up all the time.
Okay, so, I'm gonna write some things up here and then we'll, talk about it. And all of this sets the stage for what you're gonna be doing. I'm gonna do some like, like real examples of all this too, so don't worry. I don't like red, I'm not writing red anymore.
Me too.
Alright, so,
How do you like repeating on the calculator?
you don't, just hang on a minute. I'm gonna sort of teach it, just wait. That is 0.4 or 4 what? Tenths. Isn't that 4 over 10? Isn't that what 0.4 means as a fraction? So,
I don't like
anyway, clear your calculators and put in 4 divided by 10. You might get a fraction and we can change your settings.
About 0.4.
Did you get 0.4? Everybody got 0.4?
Yeah.
That has a calculator? Okay. Alright, so what is 0.1 gonna be?
1 divided by 10.
1 divided by 10. So this is 1 over 10, and this is 4 over 10. Alright, now type 1 over 9 into your calculator.
0.11.
So that is 0.1 repeating. You're gonna love this. 3 over 9. 3 over 10 would have given you dead on 0.3, right? 3 over 9. Now, didn't you know that if we pause and think about it, then it reduced to 1/3, which is
Yeah.
0.3 repeating. So what do you think 7 over 9 is going to give you?
0.7 repeating.
All right, it'll round it off a bit because of how your calculator's set. It'll probably throw an 8 at the end,
Yeah.
but it's not really 8. It's probably just rounding off that last 7. Okay? So what do you think 8 over 9 is going to give you?
8, so maybe 9.
So how in the world am I going to do 0.9 repeating?
9 over.
Exactly. What's it going to be? 9 over 9.
Wait, what?
Yeah. I led you right into it, didn't I?
Yeah, wait. Hold on a
1
second.
ninth, okay, stay with me. Yeah, it's freaky. 1 ninth is 0.1 repeating. 2 ninths is 0.2 repeating. 3 ninths is 0.3 repeating. 4 ninths is definitely 0.4 repeating. All the way up to 8 ninths is 0.8 repeating. So what is 9 ninths?
9 over it's 1. I got 1.
9 over 9 is 1. So what is 0.9 repeating? 0.9 repeating is 1. 0.9 that repeats forever just turns into 1. And kind of, if you think about it, it should, shouldn't it?
Yeah.
But isn't that a bit disturbing?
Oh, I thought you meant when you typed in 9/9, it was gonna give you 0.9.
It gives you one
Repeating.
because 0.9
Technically it is,
repeating.
but-
So, what is this? Look at the difference in this, girls. 2.999 as opposed to 2.9 repeating. 2.999 gets infinite, gets really close to 3. But what is 2.9 repeating? It's 3. So freaky. Okay, a couple other things that we need to talk about before we move on. One of them is the difference in these statements. Okay, one of those exists. 0 over 0, 0 over 4, or 4 over 0. Julia, which one exists? And we can do that. I could have, I have not brought any cookies up here, and I'm gonna divide them into 4 pieces, and you're not gonna get any, okay? So it's kind of silly, but you can say 0 divided by a number, and you just get 0. 0 can be in the numerator, and as Kate asked, 0 is a great number, okay? Now, these two, what have your teachers said about those? What word do we say? No solution, undefined? Okay. They're undefined a little bit differently though. Okay. It's always at this juncture right now that I'm a little afraid a tour is gonna open the door and they're gonna go, what in the world have you done at Marymount? These I'm gonna ask you some really easy questions. 16 divided by 8 equals what? 2. All right, 25 divided by 5 equals 5. And then you could check it by doing this. What's 8 times 2? 16. 5 times 5? 25. All right, so 4 divided by 0 is what? All right, so some people pick 1. What's 0 times 1?
0.
That's not 4, is it? So that didn't work.
So it doesn't work with.
I can't think of anything. Like there's nothing I can put here. It's called the empty set.
Oh, no real numbers.
Yeah, so there's not anything I can put in there. I can't even use any imaginary numbers in there. That doesn't have an answer. There's absolutely no answer. Girls, what I'm about to show you here is when your teachers have said undefined, there's a lot of things in our world that are undefined to us that we don't quite get. And there's a difference in these two. Okay, I'm going to tell you the answer to this one. 0 over 0, I and your teachers will still say undefined. It's a little bit different. All right, so Alex is picking 1 again. What's 0 times 1?
All real numbers. It's all real numbers.
Wait, tell me. What's 0 times 1? I accidentally turned it into an 11, but that's
It's still
okay.
0.
What's 0 times 11?
0.
It's still 0. All right, so this one's undefined because it just went off to infinity. Infinity to us, and you can say undefined, that's fine. Does anybody in here understand infinity? If you do, you need to let me know so that we can get you in touch with like Bill Gates and Mark Zuckerberg and everybody else that needs to know also, right? We don't, NASA scientists, is that weird? Like where's the galaxy's end? What if you did have a spaceship that could just take you and take you? This gave me goosebumps, like infinity, we can't understand it, can we? So isn't that weird? Realized early on I could have put in 432.6 and it would work. So do you see there's a little bit difference in 0 over 0? 0 over 0 is the one that usually gives us that super weird hole in the graph. It's like a black hole where you just fill in and you're falling forever, okay? All right, so now let's do a couple of concrete problems before we go because we leave at 1:35, right?
Yes.
Yeah.
All right, so this is what we're going to do. Let's go back to the simple problem that I started with. Y equals 3 over x. These are things I'll get you to do. You have a vertical asymptote, that's VA. I don't know how the word translates. Is it asymptote?
I feel like there might be a P. Oh, wait, with the end with that?
I'm just asking Clara, like what it would be. It's a dotted line.
What does it mean?
Well, let me grab it and you tell me if you've seen it, okay? A vertical asymptote is what makes the bottom 0, the denominator 0, as long as the top is not also 0. Now all of a sudden we see that we're really worried about the two different situations that can happen. So first, check and see what makes the bottom 0, which is real easy right now, it's 0. Does it make the top 0 also?
No.
Okay, it doesn't. That means this thing is badly broken and it has a vertical asymptote at x equals 0.
Is an asymptote different than a vertical asymptote?
Okay, there's 3 kinds of asymptotes, okay? And I wish I could take the word asymptote out of every single math book that was ever written, and inside of it put the word guideline. There's asymptotes all over our world, okay? I don't know what Clara's dress code, was it different? Did you wear a different uniform here than you do at home? So when she
They don't have a
came to,
uniform.
oh, well, there you go. So she had to find guidelines in a hurry because they don't have a uniform. So now she looks like us, okay? Because she found out what our guidelines were. You know, when you go to work, when I started working at Marymount from a different school, I had to find out what the asymptotes were. What were the guidelines? At home, you know what your guidelines are. You have to be home at 11, and you've got to be really close to 11. If it's 11:02, maybe you're not in trouble. But if it's 12:30, then you're probably in trouble, and you probably will get some privileges taken away from you, okay? So we all have these guidelines in our life. They painted them down the streets for us. Do y'all see all these dotted lines painted on the streets? Taxis are supposed to follow them. In New York, they don't so much, but in other cities, you know, as soon as you leave the city, you or your parents are driving in the lanes, right? I don't think they don't even bother on 3rd Avenue to even paint the lines on there anymore. But in other places, they've actually given us asymptotes. So asymptotes are just guidelines. Notice that I didn't say they were guides. They're guide what? Lines. What types of lines I can have? There's only 3, so help me think of them.
Linear.
Okay, that's a line. What shape? How would it start? Horizontal. They're all straight if I say line. There could be a horizontal line, there could be a vertical line,
Diagonal.
and there could be a slanted line, diagonal line, okay? So those are the 3 kind of lines. I can't think of anything else. Can you? Horizontal, or it could slant, or it could be straight. I can't think of anything else. Are y'all okay with that?
Is a parabola?
No, that's what Nazareth was saying. If I say line, it's linear, it's straight, okay? So an asymptote is observed in mathematics. If you say the word asymptote, you're talking about a line that's gonna guide you. Asymptotes are your friends, okay? For instance, what they do is I draw them in these dotted lines, and I don't drive in New York. I sold my car when I moved here. But I know that when I was driving my Jeep in Memphis, and if they were redoing a road down there, like resurfacing a road, I didn't like driving on it until they had painted the lines. It's so confusing, especially if it's a 2-way street, or even if it's a 2 lanes on each side. You don't know where you're supposed to, it's unsettling to not have a guideline. If I all gave you a craft to do today, like for instance, I think you all did that wonderful box project, or maybe.
That was
Why is that
so
like,
stressful.
it was
That was
at the
worst.
end of the year and it was 65% of our grade, and so like, I had a good grade and
Is this
it
DC's class? And Mr.
Yeah,
Mills,
we
we
did.
had no idea how to do it.
We didn't do that.
Okay,
And it was like the
Anyway.
week of history fun.
anyway, girls, listen, stay with me, cause we got time crunch now. What every single one of you did, except Claire, you printed off first something with like, it was this big thing that looked like, you know, this. I'm just trying to make one up. It was this big blob of stuff with all these lines on it, right?
Yeah.
And that's a horrible representation of it, but you planned your net ahead of time, and then you at least could be successful in folding on those lines, and it actually met. Can you imagine if you didn't know how to make a net? Y'all know what I mean by that?
Yeah.
Getting it to be in that shape would be horrible. But you printed off your own asymptotes. Weren't they just full of all those lines, and you folded on the lines? So when I've done a craft like as a little kid, I'm so glad I cut on the dotted line, I folded on the dotted line. If you know somebody that sews, they sew along a dotted line to make seams and shirts and stuff. Dotted lines are our friends, okay? If I just gave you a bunch of material and said, make me a dress, that would be really difficult without the dotted lines, right?
Dakota could do it.
Okay, but I guess you need dotted lines.
I actually don't use patterns.
Okay. But you know what they say.
She's too good. She's
No, I
too
just
good.
don't like, I don't know. I guess it would be easier, but yeah.
So anyway, they're guidelines for us to follow. Alright, so we will have vertical asymptotes, VAs. We will have horizontal asymptotes. And we'll have slant asymptotes. So we'll have horizontal asymptotes, you likely can call them HAs. You can have vertical asymptotes, you can call those VAs. And slant asymptotes, the fancy word for that is oblique. In case anybody ever says oblique asymptote to you, I had a student who went off to college and sent me a message like, oh my gosh, I didn't learn about oblique asymptotes. I'm like, oh yeah, I forgot to say that. It's slant asymptotes going with your life, okay?
Why would you call
So-
your teacher and say, you didn't teach me this once you
I
can
talked
talk
to a lot of my students, like, I keep
Okay.
in touch with them. It wasn't like,
Was
you
it
did
like,
this wrong. It was like, oh,
I just can't imagine.
you're yelling.
Just calling up your teacher just to let them know.
Hey,
Hey, you didn't.
Going to a couple of weddings
Hey,
this
you
fall.
didn't
So
prepare
we can invite me to your wedding.
Probably.
Okay,
Miss
so
Martin,
Literally.
oh, I'm sorry.
She'll be like, who
Did
are
I
you?
say I wanted to teach you?
Yeah, she
She doesn't know any of our names at all.
Yeah, no, exactly. That's okay. That's what she
Yeah,
said.
Mia got roasted
Stop.
yesterday.
And listen.
I was like,
Okay, no, stop and listen. So what you're gonna do is this. To find a vertical asymptote, you check and see what makes the denominator equal to 0. And then it might be a vertical asymptote. So this one's pretty easy. What makes the bottom 0 is x equals 0. You'll ask yourself, what does it do to the top? Does it make the top 0? No. And so you actually have a wonderful dotted line to start helping you with your graph. There's my vertical asymptote at x equals 0. Horizontal asymptotes, I'll give you 3 things about those in a minute. Horizontal asymptotes, look at my hands. They're horizontal, but they're also going out to infinity and negative infinity. A horizontal asymptote is not about looking at the nitty gritty like we've had you do in math class. It's about getting back and looking at the big picture. Okay? Things look really different from far away. When I see a picture of a graduating class, I see a lot of white dresses with red roses. I don't really get a sense for each individual girl's dress like I do when they're coming into the lobby. If I'm walking by a fire drill, I get a real good sense of the Marymount uniform, as opposed to if I look at you individually, I won't get a different idea, okay? Do y'all see what I mean about the big picture? Okay, so horizontal asymptotes, remember me doing my hands this way, it's about the big picture, okay? So you're filling an infinity. What if I brought 3 cookies in here and all 11 of you wanted it? And then they found out in the faculty in the faculty over there that I had cookies in here, and they're like, but we want a piece. And then the lower school found out I had cookies in here. I'm like, I only brought 3. All right, 3 divided by 100. How much cookie are you gonna get? This one's gonna gravitate toward what? 0. Okay. And so my horizontal asymptote is y equals 0. So it looks like this. Y equals 0. These guidelines are my friends, okay? Because now I only have to find a few more points to know how to graph it. All right, so I'm going to fill in 1. Now I'm just going to find a few points. What's 3 over 1? 3. And I guess I'll fill in 5. I'm just picking numbers. What's 3/5? Something less than 1?
Yeah.
And do you see how it fits in here between these asymptotes? Do you see how this graph is trying to drop and it gets guided off? Follow me. It's just like a lower school teacher saying, follow me to lunch. The graph just follows it off, okay? Now I'm going to pick a number back here. -1 gives me -3. -5, I just picked that out of the blue, gives me -3/5.
Oh my goodness, when it goes like that.
Yeah. And so you have a graph that like is kind of weird looking. It's this infinity business is bizarre, but it describes what's happening in a rational graph. Your homework, I will email to you a document. It will not be out of the book. You will need your calculator, or you could use your computer, whatever. I won't be with you. I won't know what you're using, but it's best to use your calculator when you can, so you're used to it. You'll be doing like a discovery activity about this, and then we'll solidify it more and spend some time on it before the test. Have I don't got a test date for you. It won't be next week.
It will be.
Will not be next week.
Okay.
Good, because I'm
Hey girls, one more thing is please be on your way out the door, so you won't be late to class. One more thing, and I don't want to spring this on you, but it'll be easy, I think. You will have a quiz next class, but I'll open up Delta Math. It was like your homework for today. When you come in,
Delta Math.
it'll be a Delta Math quiz. When you come into class, first thing we'll do, you'll log on to Delta Math. I'll reopen it. Let me clarify. I'm going to open it so you can practice on your own. I won't even check it. Then when you get in here, I'll click a button. It'll reopen, and you can do as many as you want to in 10 minutes and make 100.
And it was like tonight's homework?
Yes, yeah. So it's not this new stuff, okay?
Oh, so make 100.
You can, as long as you know how you're doing Delta Math?
Yeah.
And you can see your score? So say I give you 10 minutes, Ava,
Yeah.
but